In the final topic of today's lecture, we will review some of the preparative methods that are used for making alcohols. We'll talk about some additional preparative methods next time, but it's important to realize that so far we have already learned several different ways to make alcohol, and this will be a good point to review. The first and the simplest one is making alcohols by SN2 reaction, where we have some good substrate, primary substrate, which can be treated with OH minus to give us a primary alcohol. This reaction competes with an E2 reaction, and the alternative would also be an SN1 reaction. We have a tertiary substrate. We could simply hydrolyze it, for example, with bromide, to get to an alcohol. But again, this reaction competes with the E1 reaction. So substitution reactions necessarily are not the best way to go in the preparation of alcohol. One of the methods that are more desirable is preparation of alcohols from alkenes by hydration. This reaction takes an alkene, exposes it to water, and under acidic conditions and often elevated temperatures, we get an alcohol. This reaction will follow Markovnikov's rule that will get the more substituted alcohol, and since it proceeds through a cation, it is also subject to rearrangement, which are undesirable. So in some cases, we do get the most stable cation, and then we don't have to worry about it, but in some cases we don't, and in those cases, the better route to go is to use oxymercuration, followed by demercuration. What this sequence of reaction does is install an alcohol, again in the more substituted position according to Markovnikov's rule, but since it avoids carbon-based cations, all cations are mercury-based, it avoids rearrangement, and so this leads to the same result, but under more predictable conditions. Okay? In cases where you don't want Markovnikov's product, we'll probably go for hydroboration, followed by oxidation. This sequence of reactions uses boron-based reagents such as borane to initially give us this boron compound, which is then hydrolyzed under basic oxidative conditions using hydrogen peroxide to give us an alcohol in this case, but with the orientation opposite to that predicted by Markovnikov's rule. So this will be an anti-Markovnikov alcohol. Okay. Another way to make alcohols would be from acetylides and carbon compounds. As we've seen a little earlier, 1 or 2 lectures ago, when we talked about acetylides, so that they're good nucleophiles and that they can attack carbonyl compounds. In this case, this will be a ketone, and generate an alkoxide, which upon protonation will give us this fairly complex alcohol as the final product. Okay. And finally, in cases when we don't want to make just a monoalcohol, but a diol, we can rely on dihydroxylation of alkenes. And this is again a pretty versatile method because we can use 2 different reagents. We can either use potassium permanganate hydroxide base and water, or osmium tetroxide and hydrogen peroxide, to achieve the same effect, installation of two OH groups onto the former carbons of the double bond in a syn fashion, so this will be syn dihydroxylation. We could also get to the anti-dihydroxylation by the hydrolysis of epoxides, which can be formed from alcohol. At this point we will stop, and next time we will resume by talking about the synthesis of alcohols, and we'll start slowly getting into the reactions of alcohols themselves.